Yes, guys, we are here again to continue indices. Very important topic in mathematics. Okay, this is indices part 3. Like I said, we'll have to continue from the examples on root power law because they are also important. So, not in order to avoid wasting our time, talking too much, I've given examples of um, root power law here. Like I said in part 2, the root power can be 1/2, 1/3, 1/4, 1/5, 1/6. It can continue like that. So here 27 raised to power 1/3 is the same thing as third root of 27. The meaning of third root of 27 is that what can I multiply 3 times to give me 27? If I cannot multiply any value to give me that value inside the square root, then leave the answer as it is. Okay, so but if I can, you can press your calculator. There's a way you can press third root, fourth root in calculator. So but if you're not using calculator, of course jam will not give you something very very too out of range. Okay, they will give you something you know that yes, you can play around with when it comes to third root, fourth root, fifth root. So in this case now I can multiply 3 times to give me 27. 3 times 3, 9. 9 times 3. This one is the same thing as 3 times 3 times 3. So this is exactly what we call third root. I can multiply 3 times, which is this third root, 1/3, third root, to give me what? 27. So it means that I can multiply 3 times, okay, to give me 27. 3 times 3, 9. 9 times 3, 27. That is what we mean by third root of what? 27. The answer is what? 3. If you press your calculator, you'll still get 3. So the same thing applies for 16. For the root power here is what? 1/2. So it means I've mentioned this in sort, okay? If you remember, that square root is the same thing as power half, okay? If you've not gone through the sort part, please ensure that you go through it so that you can understand exactly what I'm saying. So now 16 raised to power 1/2 is the same thing as square root of what? 16. Okay, this square root means 1/2. But if you now have value greater than 2, then it means you have to indicate it like the first example. So square root of 16 is what? 4. It means that I can multiply 4 2 times. This one is same thing as 4 times 4. Okay, so 4 times 4 will give us what? 16. So square root of 4, press your square root of 16 will give you 4. So the same thing applies here. 81 raised to power 1/4. This is fourth root. Okay, fourth root is 1/4. So I can rewrite this one as square root of this 4 here. Don't forget, this 4 is inside. It's inside, not beside. It is when we're doing sword, you can write it beside. In sword, we write it beside like this. Okay, very, very important. Please don't miss it. Most of the time, it's inside. So this one is not the same thing as this. Very important. It's not the same thing. Always note that this like this is not the same thing as this. So don't forget 4 root of what? 81. It means what can I multiply 4 times to give me 81? So it means that I can multiply 4 times 4. Oh, I can multiply 3 rather. So 3 times 3, 9. 9 times 3, 27. 27 times 3 will give me 81. So it means I can multiply 3 4 times to give me what? 81. So if you do this, you will still get this. So at the end of the day, the answer is 3. So if you press your calculator, the scientific calculator, how to get fourth root of 81, you will still get 3. Okay, but in jam, you will not be allowed to use calculator most times. So all you just need to do is that, okay, you should know that, okay, yes, what can I multiply 4 times that can give me 81? So it's what? 3. I'm using alphabet here because sometimes you could see alphabets. So b raised to power 1/4 is same thing as, you see that my 4 is inside this curve here, so which is b. So sword, this one is like sword, this one is like normal multiplication using calculator. The same thing applies here. M raised to power 1/b is the same thing as b is inside, then m. So it's as simple as that. So the last but not the least in law of indices is the one for fraction index or power law. Fractional index, fraction index or power law. Like I said, index is the same thing as power. Okay, and I indicated it with this general, notation. So C here is the same thing as base, okay? M over N is fraction. I mentioned this in part one in sort. Example of fractions, improper fractions, I've mentioned that in part one in sort. So this is the power here is fraction. That is why they call it fraction power. So in this case, if you want to represent this, it's something as, don't forget, for n will be here, which is what we've done under the power law. Then for the m at the top here, you bracket everything and raise it to power of m. Let me give an instance here. If you have an example of this, okay, you have something like this. Let's say you have 9, 2 raised to power. Let's say, okay, let me just use 27, 2 raised to power 3. Okay, so the power here is 2 raised to power 3, and that's this is the fraction, this is the fraction, then this is the base. So the base here is representing C, in that my general denotation. Okay, now it means that I can rewrite this as this. Look at the denotation. This one is the same thing as 27, that's 3. Okay, you see that my 3 is inside, all raised to power what? 2. So it's as the same thing as what? This notation here. So what's my C here? My C here is 27. My M here is what? Is 3. Then my M here is what? 2. So that is fraction power law. So this one is fraction power. So this is the last, if I'm not mistaken, this is the last law that we have under indices. So in this case here, don't forget 3 root 27. I've mentioned this here. 3 root 27 is the same thing as what? 3. So it means that this is equals to 3 raised to power what? 2. So it means I can multiply 3 times to give me 27. So the answer is 3. So 3 raised to power 2 is the same thing as what? 3 times 3. Don't forget indices. I pick one base, okay? I pick one base, add the power, which is still the same thing as this. So 3 times 3 is what? 9. So that's the answer. It's as simple as that. So when you see this in maybe in objective part, okay, or perhaps during JAM or during GCE or during NECO, okay, anywhere you see it, maybe in your classes, maybe your teacher gave you an assignment, or perhaps he gave you something to play around with in SS1, in SS2, in SS3. So all you just need to do is just to understand those laws. Those laws are simple. I've been able to simplify it, okay, in part 2, in part 1, and I've given an example so that you can play around with. Okay, the more you solve questions in mathematics, the more you understand it better. Okay, so now in this case, so I can go ahead and give another example here. I can just say, okay, I can just say 8. I can say 8 raised to power. That's let me just say 4 over 3. So this is another example here. This is one example. So how can I represent this? I can represent it. I can just say, okay, this is my value here. I can write this one as what? Third root of 8, all raised to power what? 4. It's as simple as that. Okay, that is the power of the law in indices. It helps you simplify it to reduce your stress of writing 3 times 3 times 3 times 3 times 3. You're wasting time. So we have indices that can simplify it for you, and you go straight to the answer. So what can I multiply 3 times? That's the meaning of this. What can I multiply 3 times to give me 8? That is 2 times 2, 4. 4 times 2, 8. So it means the answer here is what? 2, all raised to power what? 4. So it means I can multiply 2 3 times. That's the meaning of this. What can I multiply 3 times to give me 8? This one, in this case here, what can I multiply 4 times to give me 81? In this case here, what can I multiply 2 times to give me 16? In this case here, what can I multiply 3 times to give me what? 27. Okay, so this, but in this case here, what can I multiply 3 times to give me 8? And this is what? 2. So 2 raised to power 4, you can, it's the same thing as 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So it means the answer here is 2 times 2 times 2 times 2. So instead of you wasting your time and be writing this, the indices, or we don't have time in indices. Indices has make it simple for us, okay? Because this one is something that if I take one base, 1 plus 1 plus 1. So all I just need to do, I can do the calculation or press my calculator and get my answer out. So 2 times 2, 4, 4 times 2, 8, 8 times 2, what? So it means the answer here is what? 16. It's as simple as that. So it's just like chin chin and pure water. Now, if you look at this, this is the first questions I share under division and multiplication law. I intentionally coined this out as one of the past questions that we have. Okay, I had to work on it and coin this out so that you can understand the multiplication law and the division law if you're following, and I believe you're also following. So if you look at this here, I'm trying to play around with the laws. Look at the base. If you look at the base here, this is the base, this is the base, this is the base. Okay, this is the base. The multiplication law says that pick one base and add the what? The power. It's as simple as that. So it means I can say this is 2, 1 minus y, okay, plus 1 minus 1. So I pick one base, 2, add the power, 1 minus y plus y minus 1 all over 2y plus what? 2. It's as simple as that. So what do? I can expand this bracket at the power here. 1 minus y. Okay, this is plus, so it's still plus y, plus y. Now plus times minus is what? Minus. Okay, and then this is 1. You can still have your 1 all over what? 2y plus what? 2. So it's as simple as that. Then you can now have, look at it now, minus 1 plus 1, minus y plus y. I've mentioned that in third part, okay? So minus y plus y, minus 1 plus 1, minus 2 plus 2. It will cancel each other. So it means minus y will cancel what? Plus y. 1 minus 1 is what? 0. Very simple. So this one is 2 raised to power 0. Then you have 2 raised to power y plus what? 2. It's as simple as that. Don't forget, I told you there's always one here, but we don't write it. There's always one here, we don't write it. Okay? So minus y plus y will cancel each other. Minus 1 plus 1. If you press your calculator, you get 0. And if you look at this too, this is 1 minus 1 is also what? 0. So you can see that's 2 raised to power 0. And this one takes us to what? Our zero index law. Anything raised to power 0 is what? 1. Okay, it's as simple as that. So if you look at this is the same thing as saying 2 raised to power 0 divided by 2 raised to power y plus 2. You can see now, this is just to explain multiplication and division law. Look at it, pick one base and do what? Subtract the power. So this is what? That's 2, 0, 0, 0 rather. That's y plus 2. Do you see it now? So it means that this is the same thing as saying, I can say 2. If you look at it, minus plus plus, there's always plus here, but we don't write it. Okay, minus plus plus will give you. So at the end of the day, you have, this is the answer, y plus 2. Okay, y plus 2. That's just the straightforward answer. So this is just the solution. I understand that some of the comments that you have been saying that I should solve it, I should solve it. This is the first question, and I've been able to solve it. It's as simple as that. All I just need you to do is just to share the answer for me, that 2 raised to power. Even if you don't know how to denotate it, all you just need to say at 2 raised to power minus into brackets y plus 2. So that is just the answer. So now, the real question under this part, I will still share it so that you can understand the beauty of what this indices is all about. So please, we'll also, all the questions we shared in the past on the sword, on the factorization, we'll still touch base with them. Okay, we'll be solving them one after the other. Okay, we are not rushing. We are taking our time to ensure that anybody that picks this particular online teaching, either in the future or perhaps currently, then we'll be able to sit down and understand exactly what indices is all about. They are just like chin chin and pure water. So ensure you continue to like, share. You are not, sharing because for sharing sake. You are sharing because those that needs it, the young minds, even if you don't need it, the young minds will be able to learn, and they will be able to share to their neighbors, to their children and nephews, cousins, so that they can understand that mathematics is simple and is interesting. Thank you very much. Cheers.